For blood test number 3 in 2025, when using Dr. Morgan Levine's biological age calculator, PhenoAge, we saw that my biological age was 34.8 years, which is 17 years younger than the chronological. Now, if you missed that video, I'll link to it in the right corner. Now, anybody can enter data into a spreadsheet, as I have here. So in today's video, we'll take a deep dive into the full lab test report and analysis. And that's what we'll see here, starting with page 1 of 4 of the blood test report. And note that I don't go to my doctor to get these tests done. I go to ultalabtests.com where I order exactly the test that I want. And then I bring the lab form to Quest Diagnostics. And then I got the majority of these, or I got all of these results within 3 days, as we'll see here. So I tested on April 22nd around 8 in the morning, and I had all of these results, 4 pages of data, 3 days later. And the majority of these results were ready within 24 hours. So if you're into blood testing like I am and you'd like to help support the channel, you can do that by using the affiliate link in the video's description. Now, although I'm focused on PhenoAge or biological age as a part of the overall approach, note that I'm not solely focused on those biomarkers, as that clock and many other biological age clocks have weak spots. So I'm trying to cover as many organ systems, biomarkers of as many organ systems as possible to leave no stone unturned. Now, in terms of weak spots, that's where we'll start. And one of my most major weak spots is Candida IgG. So you can see that it's 1.1 and it's high, and this is higher than the lab's reference range. So what that indicates is that at some point in the past, I had an infection, a Candida infection, and this isn't a recent infection. As you can see, IgM is not elevated. So that suggests this is a past infection, not a recent one. Nonetheless, that IgG for Candida is above the reference range. It suggests that my immune system has to work harder than it should to help keep systemic Candida in check. And note that these aren't just numbers on a page. I have, unfortunately, 2 of my toes that look like fungally infected. Now, whether it's local to my toes and it's not grossly systemic at other places, I don't know. But I'd prefer to help my immune system by reducing systemic levels of Candida IgG. With that in mind, I've tried following the correlations with olives. For whatever reason, olives through 10 tests are significantly correlated with lower IgG in my data. So I bumped up olive intake by a lot. Now, whether that'll make a dent, we'll find out on the next test for a May 27th test. But if it doesn't, I met with my dermatologist who prescribed fluconazole, which has been shown to reduce systemic Candida levels. So if olives don't do the trick for whatever reason, if Candida levels stay higher than the reference range for now 10 tests in a row, as you can see, as I've illustrated here, I'll go to fluconazole, which is hard to say for me. After the May 27th test, I'll take that for 2 weeks and then do a mid-June test, only testing Candida IgG to see if I can finally bring it lower to the reference range. And this story may go back as far as 2017, as I have a singular test in that year for Candida IgG, and there too, it was higher than the reference range. Now, another potential weak spot, semi-weak spot though, is DHEA sulfate, which is an androgen that declines during aging. Now, youthful levels of DHEA sulfate are 300 micrograms per deciliter, and about 20 years ago, I had 2 tests with values in that range. But I don't know if those were my youthful values, or I was supplementing with DHEA at that time, which would explain relatively high DHEA sulfate. So I can't say which it was because I wasn't taking careful notes, unfortunately, 20 years ago. The good news, though, on the other hand, is that my DHEA sulfate levels have been stable over more than 20 tests for the past 3 years, somewhere around 125 micrograms per deciliter. So there's good news in that I've resisted a further age-related change, but the plan is to improve it and get it back to 300 if I can, without exogenously applied prescriptions, at least for now. On the other hand, the RDW, which is one of the major predictors or the major predictor of Dr. Morgan Levine's PhenoAge, is good news at 12.0. Now, in terms of what's optimal for RDW, it's 11.4 to 12.6, and that's based on a study of 3.4 million people for all-cause mortality risk. The other side of that is that RDW increases during aging. So this isn't just keep it at 12.5, it's avoiding an age-related increase within one's own data. For example, it could be 11.5, 11.7, 11.9, 12.1, 12.3, still within range, but increasing over time. So the goal for RDW is to resist its age-related increase and to keep it within this optimal range. And if you're wondering where I'm getting those data from and you'd like to see that data, I have a new Patreon tier dedicated specifically to what's optimal for biomarkers. This tier currently involves more than 2 hours of video content, and I'm planning on expanding it over time for all of the 29 biomarkers shown here, including RDW. And as I mentioned, coming soon, so I'm going to add to this tier, are what's optimal, not just based on heart disease mortality risk, but also all-cause mortality risk for ApoB, ApoA1, and their ratio. Now, also on the list are lymphocytes. So in terms of how I'm doing there, for those who are familiar with the channel, you know that for the past year or so, around 10 tests, lymphocytes have been moving away from what's optimal around 2,000, as values around 2,000 are more likely to be found in 20-year-olds, and values around 2,000 are associated with lowest all-cause mortality risk. As lymphocytes decline, both during aging and in association with all-cause mortality risk, there's an increase in all-cause mortality risk. So my data has been moving in the wrong direction for the past 10 tests or so. Now, this test is slightly better than the last, as last test was 1267. This one is 1343, so it moved in the right direction. I was expecting a bigger bump, though. So stay tuned for my plans to further improve lymphocytes. And I've made a few changes for the next test. Some of that I'll cover in the next video in the series in terms of dietary changes and supplements. So stay tuned for that. Now, a new addition to the testing protocol is beta-2 microglobulin, or B2M. Now, this may seem like an obscure biomarker. Probably many have not heard of this biomarker, but to illustrate its importance, B2M is one of the strongest predictors of the DNA methylation clock, GrimAge2. Now, if you missed that video on GrimAge is the best or close to the best epigenetic clock when comparing other epigenetic clocks for their association with all-cause mortality risk. And just like RDW is a major predictor of phenoage, B2M is one of the major predictors for the overall GrimAge score. Now, rather than having the epigenetic prediction of all-cause mortality risk, I'd rather have the actual biomarkers that went into that prediction. And B2M is one of those biomarkers. So my plan is to include B2M for every test going forward. And in terms of what's optimal, lower is better. And I'll have a video on that coming soon, whether that'll be on YouTube or Patreon yet. I haven't decided. But keeping it relatively low is the plan, as its higher levels would be associated with an older GrimAge, which is bad news. In my case, 1.53 is good news. How low, though, that I can go, we'll find out, as this is a new addition to the testing protocol. All right, so on to page 2 of the report. And another GrimAge predictor, or that was used for the overall GrimAge algorithm, is Cystatin C. So for those who are into blood testing like me, Cystatin C may seem familiar as a kidney function biomarker, which it is, but it's, again, also an important predictor of GrimAge. So with those two things in mind, I'm going to continue to measure Cystatin C for every test going forward, not just for kidney function, but also for its GrimAge, because it's included in GrimAge. In terms of my data for this test, 0.83 milligrams per liter may not seem high based on the reference range, but this is my worst data over the past 4 tests. Or actually, I only have four data points, but I'm going to keep measuring it over time. In terms of what's optimal, based on all-cause mortality risk and what's found in youth as opposed to how it changes during aging, less than 0.7 milligrams per liter. And again, those data, those images, and the references are on the what's optimal tier on Patreon. So when considering less than 0.7 is optimal, 0.83 is moving away from that. And in terms of my own data, I've had Cystatin C values of 0.72. It's just a matter of discovering the recipe, diet and supplements, mostly diet though, that can help keep it closer to 0.7 or lower. And because I only have 4 data points, there's a lot of noise in the data, so it's very hard to say what may help keep it relatively low. But stay tuned for that story, as I'm planning on testing for every test going forward to discover that recipe. All right, so then some good news is our levels of free T4 and free T3. These are thyroid hormone biomarkers. And the reason these are good news is because FT4 went down and FT3 went up. And that's important because their ratio, so the conversion of the inactive thyroid hormone FT4 into the active thyroid hormone FT3 declines during aging. So that ratio, FT3 divided by FT4, declines during aging. So with that in mind, my ratio has been around zero point 0.2 for every test since last year. But for this test, it was my highest to date at 0.33. Now, I wish I could say I got there by following correlations with diet and supplements, etc., which I do for all biomarkers or all of the major ones. But when considering that I'm hypothyroid, I was diagnosed with hypothyroidism in my 20s, thyroid gland atrophy based on ultrasound. So I've been taking thyroid meds since then, almost exclusively levothyroxine. Fortunately, I was able to find a doctor in Boston. My endocrinologist canceled my appointment when they found out I was going to try to switch to some T3 and less T4. But my doctor was willing to work with me on this as I showed him all of the published data. And we reduced my T4 dose and increased or added T3. Now, that was the first step. I've since added a bit more T3, and I'm going to reduce T4 by a little bit more to further increase that ratio. In terms of what's optimal, just without going to the what's optimal tier on Patreon, but that data is there. Those images are there. Those references are there. Less than 0.8 for FT4 is the goal, and greater than 3.2 for FT3. So I'm almost there, but I've got to make another dose titration to get there. All right, then good news, and onto some liver function biomarkers, including albumin. Albumin at 5.0 is good news as it declines during aging, so I want to keep it relatively high, and around 5 is good news, as almost all of my data is around 5. Alkaline phosphatase at 45 is also good news. Less than 48 is associated with lowest all-cause mortality risk, and that's a meta-analysis of about 9 million people. And again, these data are on the What's Optimal tier on Patreon. But then adding some more context to the liver function and health story is that AST and ALT increased, and they moved away from the What's Optimal high teens, low 20s to values that are moving in the wrong direction. Now, in terms of biomarkers of liver health and function, while they are generally good ones in terms of liver disease mortality, GGT may be a better biomarker, at least in a head-to-head matchup where GGT was compared against AST and ALT. So with that in mind, my GGT at 11 is good news, as values less than 12 are associated with lowest all-cause mortality risk, and then as GGT increases, that's associated with increased all-cause mortality risk. So the overall liver health and function story is good news, but I do have room for improvement with AST and ALT. And then for another biomarker that may seem obscure is Immunoglobulin G. Now, the importance of IgG, this is the total IgG. So Candida IgG is a subfraction of the overall IgG that circulates in blood. So the importance of this is that reducing IgG extends lifespan, at least in mice. And if you missed that video, I'll link to it in the right corner. Additionally, interventions that reduce IgG in animal models, including calorie restriction, parabiosis, and exercise training, also reduce IgG, which suggests it has an important role during aging and potentially in longevity. So with that in mind, I'm going to include it for every test going forward. Now, in terms of what's optimal, that's a bit tricky because it may be an inverse U-shape. There aren't very many large epidemiological studies in terms of hundreds of thousands of people, very small studies in terms of hundreds to a few thousand people, where IgG increases during aging. But this is up to around 80 years. After 80 years, I haven't come across any data on how IgG changes during aging. And if anyone's come across those data, please post it in the comments. I'd be happy to give you a shout out in a future video. So with that in mind, and as far as I know, there is no all-cause mortality data, large epidemiological studies for IgG. So that makes discerning what's optimal a bit tricky. And when I say what's optimal, I mean within the reference range. So clearly, I don't want to be higher than the reference range because having IgG too high, at least based on the animal studies, may be bad for longevity. But on the other hand, are values closer to 800 optimal, 1100? I don't yet know, and one way I plan to address that is by testing IgG for every blood test, so at least 8 times per year, and then doing a biomarker versus biomarker analysis, IgG versus around 25 to 30 other standard biomarkers, to see how it looks in comparison, whether relatively lower would be better or higher would be better, around 1,000 in terms of how other biomarkers look within that context. So I'm about a year away from having that data, so stay tuned for that video coming sometime next year. Now, to add a bit more context to the IgG story and its overall importance, IgG, or immunoglobulin, is a globulin. And you can see that globulins are one of the most abundant proteins found in blood. Actually, they're one of the most abundant substances found in blood. albumin is the highest concentration of any substance in blood, at least based on proteins and metabolites, as it's found at 5 grams or 5,000 milligrams per deciliter. For context, glucose at 80 milligrams per deciliter and total cholesterol at 200 versus albumin at 5,000. So similarly, globulins, total globulins would be 2.2 grams per deciliter or 2,200 milligrams per deciliter. So at least 10x higher than a total cholesterol of 200 milligrams per deciliter. Now, that doesn't mean it's more important. It just indicates that it's one of the largest trees circulating in the blood forest. And with that in mind, I find it the most instructive to not only look at small trees that may be important, as we'll see, like Cystatin C, which is at a far lower dose relatively to albumin and globulins, but also by studying and optimizing the biggest trees, including albumin and globulins, and as a subdivision of globulins, immunoglobulin, which, as you look, immunoglobulin is 1,063 in this case, milligrams per deciliter, or around 1.1 grams per deciliter. So total globulins are 2.2 grams per deciliter. So that means that IgG is about half of total globulins. So globulins are a big tree in the blood ecosystem, and within that, subdividing that, IgG is one of the biggest trees within the overall globulin context. Now, to add a third layer of why IgG is important, when comparing it against Cystatin C, which again, I'm not trying to say Cystatin C is not important. It is. It's an important biomarker of kidney function and predictor of grim age. But in terms of concentration, it's a relatively small tree in the overall blood ecosystem. When comparing its concentration against IgG, IgG is 13,000 times more concentrated in blood than Cystatin C. Now, that doesn't mean that IgG is 13,000 times more important. It just illustrates that IgG is a big tree, and I find that it's informative to measure not just the smallest trees, but the biggest trees in the ecosystem that is the blood in terms of biomarkers. All right, so moving on through the blood test report, where I agree with the reference range is that my white blood cells at 3.4 is indeed low. If we're going to discern what's optimal for total white blood cells, somewhere around 44 or 4.4 may be optimal, based on around 2,000 for neutrophils, 2,000 for lymphocytes, and around 400 for monocytes. And then you can scatter in the basophils and eosinophils, which are very low. So somewhere around 4,400 may be optimal, or 4.4. So with that in mind, I agree with the lab report that 3.4 is indeed low. Now, lymphocytes are a major factor driving that story, so stay tuned for that, again, as I plan on optimizing them over the upcoming tests. Another potential weak spot or brewing weak spot, which I'm trying to get on top of sooner rather than later, is hemoglobin, which may not seem like a problem at 14.6, but it's going in the wrong direction when considering my 56 test average since 2015 is 15 grams per deciliter. So 14.6 is moving in the wrong direction. But that's just one test in 2025. My 3-test average in 2025 is 14.8 grams per deciliter, which may not seem like a big deal, but my 8-test average in 2024 was also 14.8. Now, this may seem like nitpicky, right? 15 versus 14.8, so what? Big deal, right? But if we play this out for 50 years, and I've got a 0.2 gram per deciliter decline every year, eventually hemoglobin levels are going to be aged. And I'm trying to avoid that at all costs. So the plan is to optimize biomarkers that need to be optimized, and to maintain biomarkers at youthful levels based on my own youthful levels and the published literature. So with that in mind, the plan is to keep hemoglobin at 15 and not 14.6, 14.8, etc. Now, also going beyond just hemoglobin is glycated hemoglobin, or HbA1c, an important measure of metabolic health. So although 5.4 isn't terrible based on how HbA1c changes during aging, it increases during aging, or all-cause mortality risk, values within the 5 to 5.7 range may be optimal, with lower being better. But note that this is my worst value, 5.4, over 8 tests. And unfortunately, I only have 8 tests going back to 2015. So with that in mind, I'm going to test HbA1c for every test going forward. So we're going to have it at least 8 tests per year. And for those who will sometimes ask, what would you change? What could you tell your younger self? I wish I was testing HbA1c for every test in my youth, so I'd have the recipe worked out sooner rather than later. Now I've got to go back and try to discover the HbA1c optimization recipe. All right, so on to page 3. And a part of that recipe for optimizing HbA1c is fasting glucose, which may not seem like too high based on 94 milligrams per deciliter, as it's within the optimal range, 80 to 94, which is based on all-cause mortality risk. But it's higher than my 60 test average since 2015, around 90 milligrams per deciliter. But if we're going to play devil's advocate, it's better than expected based on chronological age for how glucose changes during aging, which expected value based on my current chronological age would be 100 milligrams per deciliter on average. So regardless of what the chronological age expected data is, at worst, I want to be no worse than my own average, 90 milligrams or 89.7 milligrams per deciliter, and a bit lower if I can. All right, so moving on to lipoproteins or ApoB, starting there. 66 milligrams per deciliter is less than the reference range. But note that those data for the reference range, and I covered this a bit in my last video, blood test number 2 in 2025 series, these data for the reference range in the lab report may be a bit outdated. So when we look at the most recent data in the largest studies that exist, and I've cited one of them here, lowest heart disease mortality risk for ApoB is associated with values that are less than 76, not 90 milligrams per deciliter. And this isn't starting in the general population. This isn't people with pre-existing CVD. For sure, if you have pre-existing CVD, lower is better, and lower than 70, as low as possible may be better. But in terms of studies that don't look at, or in studies of the general population for people who don't have pre-existing CVD, which is a study that I'm citing, less than 76 may be optimal, at least based on heart disease mortality risk. So using that as the benchmark, 66 for this test, good news. 135 for ApoA1 based on the reference range also is good news, but using that same study, and again, these data are will be on Patreon in a full video, but if you missed it, it's in the blood test number. Some of it is in the last video, which I linked to it in the right corner. In terms of lowest heart disease mortality risk, that's ApoA1 levels that are greater than 150 milligrams per deciliter. Now, I have had values for ApoA1 that are that high. I've been playing with trying to reduce my HDL by a bit, which is going to bring down ApoA1 because in my data, there's an inverse correlation between higher HDL and lower lymphocytes. Now, I may be disconnecting that at some point where I try to keep HDL relatively high while trying also to keep my lymphocytes high and assume that those two biomarkers are not connected as they are, at least based on correlations in my data. So that's a story for another day. Nonetheless, I'm planning on bringing my ApoA1 back to higher than 150 to be at lowest heart disease mortality risk. Now, a third variable in the ApoB and ApoA1 story is their ratio. And before going there, I should mention that in terms of the reference range, again, note that the study that I'm referencing is from the same first author, Waldius, and the same study, the Amoris study, as shown in the reference, is highlighted with the black arrow. So the data that I'm referencing is the most recent data for the same study published 17 years later. All right, so in terms of what's optimal for the ratio, ApoB divided by ApoA1, I'm using less than 76 for ApoB and greater than 150 for ApoA1. What's optimal may not be 0.77, but instead far lower at less than 0.5, as 76 divided by 150 is about 0.5. So with that in mind, with that restrictive ratio, still good news though at 0.49. All right, but this is only part of the story. Heart disease, although it's a top cause of death, a top 5 cause of death, it's only part of the story. I don't want to optimize against heart disease mortality risk and then miss other parts of the story, death from cancer or respiratory disease or other causes of death. So how are ApoB and ApoA1 and their ratio, how are they associated with all-cause mortality risk? So that video is coming soon. And again, I'll add it specifically to Patreon. So if you're interested in that, I would subscribe to the What's Optimal for Biomarkers tier and you'll see that story relatively soon. All right, on to the last page of the blood test report and staying with the theme of lipoproteins and triglycerides, which are found in the LDL. So my triglycerides at 60 may not seem super high, but less than 45 is associated with lowest heart disease mortality risk. So that's the benchmark that I'm trying to work towards and to get it there consistently lower than 45 for every test, not one test, but as many tests as I can infinitely for every blood test going forward. We can also see that HDL close to optimal, 50 to 60 in men at 61 milligrams per deciliter. And that's important because many people struggle with increasing or keeping HDL relatively high, and I was one of them. I've had HDL levels as low as 28 since 2015 over the past 10 years. But over the past 17 tests in a row, average HDL is 57 milligrams per deciliter, right within its optimal range. So for those who struggle with HDL and trying to keep it in that 50 to 60, at least for men, the range is a bit wider for women. It's about 50 to 75. For those who may struggle with increasing HDL, it is possible, non-pharma ways. It's just a matter, in my case, of discovering the recipe within my own diet that can help remove whatever inhibition I had from allowing HDL to be relatively high relative to the 28 value. All right, next up, hs-CRP, which is less than the detection limit at 0.2 milligrams per liter. And that's important because this is now the 24th test in a row where hs-CRP is lower than the lab's detection limit, which was less than 0.3 milligrams per liter for the first 17 tests. And since then, for whatever reason, Quest has gotten, I guess, a bit better at their detection limit, where now it's 7 tests in a row, less than 0.2 milligrams per liter. And then last but not least for the biomarkers is homocysteine, which has moved in the right direction, but I'd like to bring it even lower to value somewhere around 5, which is based on all-cause mortality and dementia risk. Now, I don't have the MTHFR polymorphism, which can lead to higher homocysteine levels than should be. I've had values around 5 in the past, about 20 years ago, and I'm not sure if that was just my youthful data or I was supplementing. I'm not sure because I wasn't taking detailed records at that time. So this isn't a gene polymorphism story, because if it was, I'd expect high levels of homocysteine way back when and no age-related increase, which, or I should say, it may not be age-related increase. It may be some aspect of diet, where there are aspects of my diet, and I won't go into that story yet, but we'll see how the test goes for the May 27th homocysteine test as I remove some stuff in my diet that may impact homocysteine. So stay tuned for that story in an upcoming video. In terms of what may have helped move homocysteine from 11 to 9, I started supplementing again with the only thing that's consistently worked in my case, which is the combination of 1,000 micrograms of methyl B12, 400 micrograms of methylfolate, and very low dose vitamin B6, 1.5 milligrams. And I started that on March 27th, so there was about 3 weeks before testing where I was taking that every day. All right, so what I haven't yet gone through in this story is what diet and or supplements underlies all of these biomarker data. And in the interest of time, I'll cover that in the next video. If you're interested in more about my attempts to biohack aging, including blood test consults, check us out on Patreon, where I post at least twice a day in other Patreon tiers. And we've got a whole bunch of discount and affiliate links that you can use to test yourself that help support the channel, including ultralabtest.com, which is where I get the majority of my blood tests, the clearly filtered water filter, which I'm using every day, at-home metabolomics. I'm up to test number 17 now for that, oral microbiome composition, and I've got some more news on that front, so stay tuned for that story, those stories which I haven't told in a while. NAD testing with Ginfinity, epigenetic testing with True Diagnostic, at-home blood testing with Cyfox Health, which includes Grimage, green tea, which I drink every day, diet tracking with Cornmeal, also using that every day, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, so if you're interested in wearing the ConquerAging or Diet Trying brand, as I've got on here, and this is the Figuring Stuff Out is My Drug t-shirt, which is a new addition, so if you're interested in getting one of those, check it out. Thanks for watching. I hope that you enjoyed the video. Have a great day.